Hey everybody, sorry I'm not there with you. We're just going to continue off from where we left off yesterday. Yesterday we were taking a look at basically the particle theory of matter, and we just started talking about some ways to classify matter. So both of my classes left off at different points, so if you've already heard this, it's a great little review. If not, please make sure to copy down the material. So we talked about matter being anything that has mass and takes up space. So we said even though you can't see it, air definitely has some mass, so it would be considered matter. You, me, toast, all that kind of stuff would be matter. And then we talked about some things that definitely aren't matter, so things like light and gravity. Even though they exist and we definitely know about them, they don't have mass and they don't take up space, so we consider them not to be matter. And there were two types of matter that we were taking a look at here. So we can always take any type of matter and divide it into one of these two categories. The first was a pure substance, and that was something that contains only one kind of particle. So like if you had a big glass of water, everything that you're going to drink in that glass would be water particles. That makes it a pure substance. When something is restricted to just one type of particle, we call that a pure substance, and we'll take a look at dividing that up in just a second. There's also something called a mixture, and that's when we combine two different kinds of particles together. So that would be like a sweet piece of pizza would be an awesome example of mixture, because you're combining tons of different things. You're combining different cheeses and pepperoni and bread and mushrooms and bacon, and if you're a little bit crazy, you might even put pineapple on that thing too. Socks are composed of a bunch of different kinds of fabrics, so we're combining tons of different particles there. So we're combining different particles together. So we have something called the matter tree. And just for the teacher, as I'm going through, if students need more time, please feel free to pause the video to give them the requisite time they need to copy everything down. So we said we had matter, and that was at the top of this matter tree. And then we broke it up into pure substances and mixtures. So those were our two little branches. But then we can branch even further from each of these things. So we can take our pure substance and we can break that down again. And we have two types of pure substances. We have one called an element, and that's when we took a look at all the different elements out there. So there's the periodic table of elements just up on the board there. We have a ton of different elements. So if you ever see anything that has a chemical formula, you should automatically be able to tell me that that is a pure substance. So an element is any one of these squares on the periodic table up here. A compound is when we take more than one of those things, mush them together, and you get a product. That product would be considered your compound. It's when we take more than one element and we mush it together. Now, instead of pure substance, you can also have a mixture. And we have two different types. The difference between them is really, really easy. We have a homogeneous mixture or a solution. And that's when you mix different things together, but if you were looking at it, you wouldn't know that there's two things. So something like that might be like Windex or Pepsi. Those things have a ton of different ingredients in them, but when you look at it, it looks like just one thing. That would be an example of a solution. But there is something called a mechanical mixture, and that's when you take a bunch of things, you mix them together, and you can see the different parts. So like that pizza slice we were talking about before, you can see all of the different ingredients in it. If you can see more than one thing, we call that a mechanical mixture or a heterogeneous mixture. So let's take a look at pure substances. So we have two types of pure substances. Number one is an element, and elements are basically as small as we go. We can't break an element down any further than it already is. So you can't just take an oxygen atom and decide to break that thing down any further. That's pretty much the basic building block. So elements are as small as we get, and there's tons of different examples of elements out there. In fact, there's about 118 or 119 right now. And if you're ever looking for an example of an element, just open up your periodic table. If you pick any one of those things, you'd be right, because they are all considered elements. Every single one of them is found on your periodic table. But if you take more than one element, now you are dealing with a compound. So a compound is when we combine two or more elements together. So things like water, which is H2O, so you're combining hydrogen and oxygen, or maybe carbon dioxide, which you're combining carbon and oxygen to make CO2. So there's tons of different kinds of compounds out there, and generally if you take an element from the left side of the periodic table and an element from the right side of the periodic table, you can mash them together and make a compound. So we're going to take a look at that a little bit later. Mixtures. So we have two types, and we talked a little bit about them before. We have homogeneous mixtures, which we can also refer to as solutions. It basically means that you can't see the difference. So that is what I'd really like you to focus on here. Homogeneous mixture, you can't see the difference. So things like Gatorade, milk, Windex, lots of different ingredients, but when you look at it, it looks like just one thing. That is quite different from our heterogeneous mixture, which is a mechanical mixture. And that's made up of two or more things, but the thing is, you can see the difference between them, no problem at all. So things like pizza, banana split, or rocks and sand at the beach, you can all see the difference between each of those things. When you look at a banana split, you can see the banana, you can see the chocolate, you can see the ice cream, you can see the cherry, you can see the whipped cream, you can see all of these different things coming together. And because you can see the difference between them, it's a mechanical mixture. Gatorade, it's got sugar, it's got water, it's got a bunch of other stuff, but when you look at it, it just looks blue or white, and that makes it a solution. So please make sure you understand the difference between it. And to the teacher, please make sure that if I am moving too fast for them, just to pause the video, or even feel free to rewind and give them the time they need to copy them down. Alright, so we have chemical reactions in our solution here. So lots of times in chemistry we like dissolving things. And we have two big parts to dissolving things. We have solutes and solvents. So the solute is the thing that we put and gets dissolved. So the solute might be a good example of that. Would be like when I'm done working out, lots of times I put protein powder in my water and I dissolve it. So the thing that gets dissolved is called your solute. So if you're making Kool-Aid, the Kool-Aid crystals would go in the water, they would get dissolved, so they are called the solute. Now, something has to dissolve the solute, and that's where the solvent comes into play. So the solvent is the thing that actually does all of the dissolving, so it does the hard work. So when you put your Kool-Aid into your water, the water dissolves it, and that makes it the solvent. So in terms of solvents, we generally consider water to be the most common solvent. Water dissolves a lot of different things, and it's the most common solvent for a reason. It does a really good job of it. So please, everybody mixes these up. Don't be that person. Solute gets dissolved, solvent does the dissolving. All right, please keep that in mind. Okay, now we've started to call the particles in our theory that we were talking about. So we said there was the particle theory. We've changed that a little bit, and now we start calling them atoms. So we now have our atomic theory. So atom is basically as small as we can get. It's the smallest unit of an element, and each element is made up of just one kind of atom. So if I had like an oxygen atom, or the element oxygen, there's no other atoms in there except for oxygen atom. Or if I had a hydrogen element, that's only made up of hydrogen. It's not made up of a little bit of hydrogen, a little bit of oxygen, a little bit of nitrogen. Nuh-uh. If it's an element, it's just made up of one type of atom. Now, atoms, they like making friends. And when they make friends, they make something called compounds, or molecules, which we talked about. Molecules are the simplest unit of any compound. So H2O, this is what H2O looks like. It has one oxygen in the middle and two hydrogen on the outside. And H2O isn't the only molecule. There's lots of different kind of molecules. And when you combine lots of different molecules together, you can get compounds and mixtures. So molecules are when we have two or more compounds come together. So they're the simplest units of compounds. Sorry, molecules are when two or more atoms join together, I should say, not compounds. So atoms are as small as we get. Molecules are when we have two or more atoms coming together. So 3 ways to separate mixtures. This won't be too heavy of a focus, but please make sure you know the 3 ways. So the first is filtration. This would be like if you had like a Brita filter in your water, you'd be able to filter out some of the sediment from your water, so you might be able to pick out some black specks. That's done using a filtration system. Same thing if you make coffee, you normally put a filter on to catch some of the sediment. Distillation, this is a pretty serious kind of example that we won't be really taking a very good look at. Just please be familiar that distillation is one way to separate a mixture. It's basically done in chemistry. If you take grade 11 chemistry, you'll be using different kind of boiling points to separate liquids in a mixture, which is actually pretty cool. Think about it. If you take two different liquids that are already mixed together, based on their boiling point, you can separate them from each other. Filtration is a little bit different because you can only separate solids. We can't really separate liquids from that. But magnets are pretty cool because they can attract iron, steel, and other metal type products and leave everything else behind. So if you were on the beach and you had a metal detector and there was some money buried underneath the sand, you could hover a magnet over it just like this, and it would attract all of the metal. So it can filter out some of that kind of stuff. So these are the three ways we will take a look at in separating mixtures. So please make sure you know this. It seems like a very good multiple choice question at some point. Now, in terms of your homework, for homework, you have those two sheets that are in your package right now. In addition, there is a practice quiz on the LMS. You should all have access to that. I have checked. Everyone does have access. So if you have time when you are done those two sheets, at the end of class, if you have a device, if you brought your phone, or when you get home, please make sure you try the practice quiz on the LMS. All right, tomorrow we'll be taking a look at 4.2. Please make sure you have your homework done.